Hi, my name is John Corder, and welcome to the Constant Pi. In this video, I am going to be attempting to explain in the simplest way I can the value of pi. The primary focus of this discussion will be using simple division to help us establish the accuracy of pi. It can be tied up in the more complex terms of math, like algebra, but I think it's more important to try and stick to the simplistic forms, like division. Whenever we divide two natural numbers between 1 and 10, there's a 71% chance we will successfully create a ratio. Unfortunately, that means there's a 29% chance that we're going to create an approximation. The list you see in this video is an approximation, a list of approximations created by simple division. Nothing complex. This is a list of those simple division problems that create those approximations. They are all highlighted in red, so they're easy to see. Nothing hidden or up the sleeve. This would be a list of ratios equivalent to the black equations in the list. Basically, the value 3.14159 is always in the approximation list, never in the ratio precise list. Understanding that is understanding the constant pi. 3.1404. Subtract that from the value of pi, that gives us a value of 119,000 between the ratios of 4 to 1 and 3 to 1. That's too close. There's something is amiss when that value is so close. The constant pi was a ratio calculated with chords to specifically be 4 to 1. The ratio itself is not in the range of 3 to 1. The list of ratios again listed between the natural numbers of 1 and 10. So this all leads to describing the p-value, then proving Q using the inference rule. So how close is too close for the Q and P value? In establishing the approximations of pi, and that value is 100% of the time not a link between a ratio of 4 to 1 and 3 to 1. How I came up with the constant pi is actually through a series of chords in which the ratio is 4 to 1 to a circumference, and I'm basically using a scalene triangle to calculate that. At the end of this video, there'll be a brief image that's expressing some of the trigonometry behind that as we go through right now, and we're highlighting again the basic division. The black numbers are the ratios, the red numbers are the approximations we create by simple division. We are dividing a circumference by its diameter to give us that approximation. These are ratios we get by dividing chords that don't give us irrational numbers. Fractions are sometimes deceiving. They don't present themselves until they become decimals. In this last image, what should be emphasized is the hypotenuse is actually the circumference, the length of the circumference. This is achieved by a form of calculus And with this, we've reached the end of the video, and thank you for watching. I hope you liked it. I really appreciate the time you've taken out of your daily activities to view it. Bye for now.